reactions. We see them everywhere, in our science labs, when we make a cake, and when we light a match to commit arson. But what makes a reaction go faster? This is what we'll be investigating today. But first, what is a reaction? A chemical reaction is when a substance or multiple substances changes into a different substance or multiple different substances. The amount of mass and number of atoms doesn't change in this process, but it is the atomic arrangement that changes. Signs of a reaction include changes of volume, taste and smell, color, temperature, formation of a solid, and gas bubbles appearing. A few things need to happen in order for a reaction to take place. The reactant molecules have to collide, but they have to collide at the right orientation and at the right amount of energy. Some reactions are slow, like the rusting of iron, and some reactions are fast, like an explosion. This is called the rate of reaction, or reaction kinetics. Sometimes, making a reaction go faster or slower will be more beneficial than it would be at its normal speed. If we want to change the rate of reaction, we can do a few things. We can increase the surface area, increase the concentration, increase the temperature, or add a catalyst. But why would we want to change the rate of reaction? Well, we may want to increase the reaction rate for a few reasons. Because the reaction is more efficient, more intense, better results, or we might want to produce more product. For example, the catalyzed decomposition of hydrogen peroxide, or more commonly known as elephant's toothpaste, is catalyzed because the reaction is quicker and more intense. Reasons for a slower reaction may be that it's safer, to observe it better, to preserve it for longer, or that it's more controllable. For example, the preservatives in some foods are there to slow the decomposition of the food. So let's explore this deeper. Increasing the surface area is a good way to speed up a reaction, as the molecules of one reactant are touching more of the molecules in the other reactant.
A good example of this is adding lead nitrate to potassium iodide in crystal form and as an aqueous solution, which is the crystals dissolved in water, increasing the surface area. When the crystals were on top of each other, only at the point of contact did it change to a dull yellow color. When all the crystals were mixed with each other, all of it turned into the same dull yellow color. When the aqueous solutions were mixed, the solution turned a vibrant yellow color.
This tells us that by increasing the surface area of a reactant, it greatly increases the rate of reaction, as molecules in one reactant are touching more molecules in the other. Increasing the temperature of a reactant increases the rate at which the molecules in that reactant move, which increases rate of reaction.
An example of this is an experiment on the effects of temperature on the transparency of a solution of sodium thiosulfate and hydrochloric acid. Multiple test tubes were put into a beaker of water, which was heated up in approximately 15 degrees Celsius intervals. One tube of sodium thiosulfate and hydrochloric acid was taken out and mixed together, pouring 3 times. A stopwatch would also start as soon as the liquids had touched. Then, someone would look at an X on a tile, and at the moment of which the X was no longer visible through the liquid is when the stopwatch would stop. The results showed that an increase in temperature saw a decrease in time taken for the X to not be visible.
This shows that increasing the temperature of reactants speeds up reaction time. Increasing the concentration of reactants increases the reaction rate, as there are more of the reactant molecules to react with.
Evidence of this can be seen in an experiment of magnesium and hydrochloric acid of different concentrations. Magnesium was put into test tubes with hydrochloric acid of 0.5 mol, 1 mol, and 2 molar, and a stopwatch would start. When the magnesium stopped reacting, the stopwatch stopped. Magnesium in the 1 mol acid stopped reacting faster than the 0.5 mol acid.
This tells us that by increasing the concentration of a reactant, it increases the rate of reaction. A catalyst is another substance which is added that speeds up the rate of reaction.
Evidence of this can be seen in an experiment of zinc with copper 2 sulfate plus hydrochloric acid. Zinc was placed in 2 test tubes, 1 in each, and copper 2 sulfate was placed in one of the test tubes, with covering the zinc with it. Hydrochloric acid was poured into both test tubes, and a stopwatch was started. The one with copper 2 sulfate reacted more vigorously and with more intense bubbles and color. However, it did not finish reacting before the one without copper 2 sulfate, as that one stopped reacting at 5 minutes and 13 seconds, when the one with copper 2 sulfate stopped reacting at 5 minutes and 53 seconds.
Where is it? Oh, there it is. This tells us that by mixing certain other chemicals with other reactants, it makes the reaction go faster. So, reactions. They can be fast or they can be slow. If you want to increase the rate of reaction, you can increase the surface area, increase the temperature, increase the concentration, or add a catalyst. We may want to do this to make the reaction go quicker, to make it more intense, or to make more product. If you want to slow down a reaction, you can add an inhibitor. This makes the reaction safer, more observable, more controllable, or to preserve it better. So thanks for watching and joining me in exploring reaction kinetics.
Don't forget to hit the like button. Yeah. And subscribe to It's Up Here. And here's another video.